Live, sir. Live.
You can start, sir.
Okay. Good morning to all. The respected resource person, Roy, Antony, Arnold, sir, from Infosys, and the Generic Talk Series coordinator, Arun Manikaraja, and Rajin Paul, sir, Nana Jasli, madam, then Jayabharti, ma'am, and all the faculty joined in the YouTube and dear students. Good morning to all. It's my great pleasure to propose the welcome address for this function. First of all, I welcome the resource person, Dr. Roy Antony Arnold, blockchain architect, Infosys, for accepting the invitation to act as a resource person for today's Generic Talk series. I welcome you, sir. Welcome.
Thank you, sir.
Next, I welcome all the faculty members, those who are joined in the Zoom link, as well as through the YouTube channel. So I welcome you all the faculty members. Next, I welcome all the students, those who are joined in the YouTube. So my humble request to all the faculty and the students, if you have any queries, please ask the resource person. Resource person is already he visited our college for the project competition also. So we know the resource person very well. If you have any queries, please ask. Please ask. One more point here in this Generic Talk series, students attended in the YouTube channel only. So students don't have the rights to ask the question. So those cases, students send the questions to your mentor. So mentor will raise the question in the Zoom link. Okay. Please, students, if you have any query, please post the question in the mentor groups. Okay. You pass the question to the mentor. Mentor will ask the question. The question asked by which student name and class, and you will post the question. So, okay. So I thank you, sir. Thank you for accepting the invitation, sir. Thank you. Thank you.
Yeah. Thank you, sir. Thanks for the warm welcome.
Sir,
Okay, sir.
so I would like to give introduction about Rai, sir. So Rai, sir, is working in the Infosys for the past 15 years. He's a certified blockchain. Am I audible? Hello?
Yes,
Yes,
sir.
Professor, you're audible.
Yes, sir. Audible.
Sir is working as a certified blockchain architect, and he is certified Scrum Master, and is having academic industry collaboration for the past 15 years through Infosys Campus Connect program. Sir is having vast experience in academics also, various reputed institutions Sir has worked. Totally, Sir is having more than 15 years of IT industry, and as an ASIL, Scrum Master, business analyst, trainer, coach, and he has guided more than 2,000 employees and trained in the agile methodologies, and he has shown proven records in the industry for improving the productivity, and he is working in the blockchain and DevOps and various projects. So today, Sir will be handling blockchain security. Already students having basic knowledge and faculty having basic knowledge in blockchain can utilize SAR's expertise in blockchain area. So already SAR has come to our college for a mini project hackathon, and so he knows about our students and our environment, and today's generic talk series will give more insight on blockchain. Students and faculty, you can utilize his expertise. So with this introduction, now I request Rai sir to deliver the talk on blockchain security. Thank you.
Thank you, sir. Thanks for the warm welcome and for sharing my profile with the audience. It's a great pleasure and honor for me to be here. And for this session, I created one small pre-activity and shared this space with Professor Arun. And
yes, sir. I was to students groups and everything, sir. I was shared.
Yeah. So this is the winner of that assessment. I'll share my screen and you can have a look at it. Hope my screen is visible to you.
Yes, sir. Visible, sir. Visible.
Okay. So this is the winner. So I appreciate the winners. who took the quiz and then got the first 3 places. Mr. Chivika, Sai, and Ritu. Congratulations. And let me get into the topic, today's topic of my session. Screen is visible and yeah.
Visible, sir, visible.
Okay. Okay. So this is a very short, time is available. So given 1 hour, within that I try to cover the very basics of this. But it's a vast area, as usual, right? Blockchain is a vast area, and the concepts when we work all are kind of different level of uh, entity involved, and in-depth understanding is needed based on how much you're strong in cryptographic functions and mathematical model, all those things. But however, I'm just trying to minimize this one, try to give a basics behind the security, why this is important, and how we are achieving it in the industry side. And as a student, can we have a career in this area? That you can decide based on how you understand the concept and how you show interest in learning blockchain. So in this area, we have various designation or various job categories are there, like smart contract manager, smart contract auditor, and then uh, smart contract creator. Then you have this smart contract deployer. And then a lot of different roles are there, but not specifically to the one combined with other small activities as well. Okay. So with this, let me get into this. What is this blockchain? Hope you already know. Just let me quickly give that one. The current scenario, most of the services we are depending on a third party. So if you see, we have in this scenario, I'm just taking on a you want to sell a car, they want to sell a car, and where a client want to buy a car, and we usually have a car dealer. That's how we usually go with this approach. If you want to buy a car in second hand, we go to the car dealer, and where the car dealer will take care of the remaining part. So when you trust the car dealer, you don't ask questions, you just go with it. So you need to trust the third party. Okay. So the day we'll give the car related documents to car dealer, will verify, and they will certify the car, and then they will estimate how much the car can be have the resale value, and they will add their profit on that, and then they will propose that price to client, and the client need to come with that financial part, whether it's a cash or bank loan or anything, right? With that appropriate information. And then the transaction will happen once. Then we need to update in the government office who's the owner of the car. That RTO office, you need to change the owner of the car. Okay, and then the auto insurance need to be changed, then created, and then your bank will have that money need to be sent to the bank account. So like this, all these are organized by the car dealer. The car dealer will take care of that money sent to that Dave, and then the documents are properly changed everything. Okay, so here the trust is provided by the central authority. You can think of your Ola cab or Uber or Swiggy. All these are you are depending on a third party, and as long as you depend on a trusted party, you'll be going with the bond. So that is our existing approach. And this third party, where we removed with the help of a blockchain by giving a transparent and decentralized mechanism. Okay, so whenever you have a third party, there is always a prone to a lot of things. Maybe so room for attack, room for cheating, all those things are possible, right? Especially wherever the human elements involved, all kind of things are unexpected. So how we are changing it in the blockchain is by understanding this a very basic concept. Always a network is more powerful than individual. So in anywhere, right? How many people come together? It's become more powerful than an individual. So that is the concept began. So in this blockchain concept, so what we do with the help of network is we try to remove the middleman and decentralizing the power and make others to know what is happening with that, making more transparent. So this is the fundamental idea. And when we do this, naturally what will happen is everyone trusts the network and no centralized authority, and the transparency, verifiability are confirmed. So think of this, a very simple basic one is, for example, the day we're selling the car, and he only knows the actual problem with the car. And the car dealer will go with that inspection, and he also come to know what is the problem with the car. And if the car dealer hides that information to the buyer, that is, Claire is not aware of that issue, and the car dealer want to make profit with that one, then naturally the Claire will be the loser because we'll be paying more money for the car which is having a lot of other issues. And here that simply Claire buys the car because she trusts that car dealer. But instead of that, if there is a kind of transparency is been established among Dave and Claire, like Claire is having a look at that how many times the car went for the remodeling or changing the inner parts, and whether the original parts are is it second quality or first quality, kind of all this information, and then is there any accident happened? All these informations have been available to Claire, can make a decision, an informed decision, whether we can trust the dealer or whether we can go to buy the car or not. So this transparency is that real problem in whenever you have a centralized model, right? So how we are coming out of this is by creating a decentralized approach, a decentralized P2P, peer-to-peer network, and where we share the information and we give the ledgers to all that entities who are involved in that visibility, what is happening there, whether it is true or not, and we'll be having that system designed, the blockchain platform designed to provide that transparency and to take action on it. So when we give this particular pattern, what is going to happen here is we are going to give that power to each party to know what is happening in that transaction, whether to trust or not. So the blockchain ledger is open to all. There is a transparency, and based on their level of access, the information provided. We have that provision in enterprise blockchain that what information we want to show, what we can hide. There's something more privacy information can be avoided. Other common information can be shared. All those things are possible. So with that, it is easy to get a consensus among all the entities involved. So all parties need to agree on that information, which is correct, and then about the asset, what they are doing on it, and then the provenance, the beginning, where it started. Okay, they can go back and trace the records. What is the source? For example, when in WhatsApp, a lot of videos are forwarded multiple times. When when a false information or when a spam is being forwarded, we can able to trace back to who originated. There is a facility, right? We can see who forwarded. If we trace back, we can able to see who is that where that image originated or where that video originated. The same way, this blockchain is providing that facility. We can trace back to the origin, and then we can able to validate that one. Okay. And immutability, as blockchain is an immutable ledger, there is no one can change or edit. Once the information is added in ledger, it is fixed. No one can change it, which means no party have the power to edit or modify that information. And then fourth thing, the final part is the finality. That is, whatever the transaction committed, when the consensus happen, then there is no rolling back, which is final. If there is no consensus, the transaction never going to happen. So naturally, we are providing the power with that decentralization power to all the entities, and this is the blockchain. This is how the blockchain works. Okay. Now, so the trust is provided by the blockchain, so no need to doubt anybody because the data, that the information is available, open to all, so you can have a look at it. Okay. So The automatically need to execute, right? That is being done by smart contract concept. So the smart contract, it's again as a program which will have a certain action which will trigger only when the conditions are met. So here, the usually when we have a kind of, for example, if I'm going to buy a land, then I will be putting a contract with a seller that I'm giving advance to this much money within 2 months or 3 months. I'll be giving you all the money, and then we will go for the registration. Either we give a contract. Now, this contract will be triggered manually. Either if I have all money in my hand, then I will trigger that contract. If I ask for the contract, I want to do the registration, I'm ready to pay the money. Now, suppose the buyer needs to, the seller needs to have, wants to have more money immediately, then he might be calling me that saying that, as per the agreement, when you're going to, do the registration because I made a made up money, we need to do this registration as quickly as possible. Like that. So the point is right. When the contracts in the business world are being written, usually it's a manually triggered. Okay, either side of the party will be triggering it manually. But in the case of smart contract, when the conditions are met, the code will automatically execute. So it's like when you go to the what is it? The ATM, right? When you give this password pin, then it will check all the conditions internally, whether you have enough money, whether the ATM is having enough money, whether your account is having enough money, and then whether it having enough number of notes which you want, and then automatically it will dispense the money. There is no third party involved. The cashier or the teller is not involved. When you give the card and you give the password, and then you see the amount, and then the machine will check whether all the conditions are met, and then it will give you the money. The same way, so this code will be executed without any intermediary when the conditions are met. Okay. So this smart contract, even though it's saying smart contract, but as a developer, we have to be very careful when writing the code because the smart contract, when it's executed, the final results are going to put into the block. That is your blockchain block, which is immutable. You can't change, you can't edit. So if anything happens wrong, if it's executed very wrongly, you can't roll it back. There is no rollback function. In our RDBMS database, we'll be having save point and the rollback option will be there when the transactions are atomic. So when any one of the statement in the transaction failed, then it will automatically roll back. But here, even if it is successfully completed, still we can able to roll back with the save point concept, right? But here, no rollback is possible because it's immutable and no single entity is having the ultimate control. It's kind of decentralized more than for example, in the case in the across world, we may have 100 million people are using the decentralized funds. All will have their own copy. Then going and changing and rolling back into all this entry would be very difficult, not possible, right? When you have the business network, only that closed certain entities are involved. In the case, for example, in our X3's example, only 5 entities are involved in that entire process. So those people need to agree if they want to roll back or change it. That will be kind of tedious process. But most of the time when these kind of things happen, we'll be doing a hard fork. That is, we want to ignore that existing one. We need to take a new one. Means we'll take a hard forking facility. I hope if you studied blockchain, Bitcoin already, you may know this. Okay. Anyway, with this, what is the real problem? Or when we say this smart contract is going to add it into blockchain, then what is going to be the block and how it is enabling us to go back and see the provenance part or the origin part, how. So when we take this smart contract in action, right, what it will do is the smart contract will have a lock or a conditions, right, which will be predefined. When these conditions met, you have to execute this. Like that, we'll have a kind of code block will be created. And then the conditions are kind of a lock. When the conditions are met, the means is a kind of a key. So when the conditions met, then your code will execute and you don't need any central authority. And once it is executed, all your code the result will be registered in your blockchain ledger permanently. And because it's kind of a consensus already there provided for the smart contract, when that transaction triggered, and then the result will be automatically added to the code block. That is your blockchain ledger. Okay. Now, in block, we have a lot of information. We can customize the block, but most of the time, the block is going to have like this structure, the Merkle tree or Merkle root, or we call it Merkle tree. This is a very basic part. I'm not here to explain this. Hope you already studied in your blockchain, because our ultimate aim of session is focusing on the security part. So I'm just giving you that the block will are connected like your linked list. It's kind of connected, and we can able to go back to the previous one where it's originated because of this previous hash. So we have the previous hash. This is what going to help us. Okay. So the previous hash will identify the previous block. In that, the previous hash will identify the previous block. So we can go like this, and no one can edit anything because all the transactions are hashed. Each transaction, the blocks or the transaction or data, whatever you're going to store it in the block, all are hashed, and then again we hashed everything into a single hash. So the Merkle root is a kind of a single hash of all the transaction. So if anybody, even if somebody managed to edit this transaction, what will happen is the entire hash value will affected, and then the block entire hash value will go wrong. And because of that, we know that this particular block is being corrupted, and it is too difficult usually to change anything after the block has been created. That is how it is being designed, right? But does it mean that the blockchain is it's more secured, or there is no problem is going to happen? It is not that way. In the structure of blockchain, if you are implementing this blockchain structure as it is correctly, the room for editing the data is very minimal, or we can say practically not possible. So then why then security is needed, right? The blockchain security is needed in terms of your smart contract, because once the data is written in the ledger, no one can change, no one can edit. In the worst case scenario, we may create a new blockchain ledger starting from scratch again, right? Because editing is not possible, So where then the hacker is pointing, or the flaws, they targeting this smart contract where the actual transaction happens before putting or pushing that data into that block, and we have some execution time. That time is they try to exploit in some way where the loophole is there, and that is where this smart contract security, or say the blockchain security, where we focus more on the smart contract part. Okay. So when we have this blockchain in place, this going to provide us provenance and traceability. So whenever you bring an enterprise blockchain, where we have a group of different type of people will be there, like we'll be having a node who is that node is in charge or is responsible for the contract creation, which means a group of people may be working from a node who create that smart contract for the business, and the another node which comes with that authority who provides that who can access, who is visible. That authority is provided by one node, and a person, a human, is going to be behind that one. And the end user who is going to use the platform will be making use of the platform. And then the distributor node who will be distributing the information across a node, or to get the consensus from the other users. So all these nodes need to be registered into the network first. That is the first step: device creation and registration. So all these devices need to be created and registration in the our blockchain network, which will happen as a first step. The second one is we do the device transfer. That is, these smart contracts are moved from the contract creation node to the actual execution node. Who is having the permission to execute the contract will be having that transfer happen. Once the transfer is confirmed, your distributor node will do the consensus algorithm, and which will check when majority people agrees on it. Then that will be finalized and then added into the blockchain network. And then the end user can able to validate at any point of time by do the device tracking and verification method within the private blockchain network. And some blockchain network provides an off-chain, off-the-chain information. For example, imagine that you are using a coffee. The coffee comes with a QR code. When you scan the QR code, that QR code will show the page in your mobile phone saying that origin or the provenance of that particular coffee, where it comes from, what are that various checks happen within that different nodes. So which, if it is visible to you, then you may have more trust on that coffee, because this information can't be modified or changed by anyone just like that. And that is the purpose of having this off-the-chain information. If anybody want, they can have an access. But that from mission also we can able to have an access. So this is that overall high-level view from the enterprise blockchain part. But when you have this proper supply chain in place, right? We will have a blockchain is involved in a supply chain area. So we'll be having that, right? Each part will be having that transfer of ownership, and then you need to get the money for that one. So it's a kind of back and forth. You are sending the product, the entity, the item, or the asset is moved to one entity to another entity. In turn, we'll be receiving some benefit. There is money or something else you need to return back. So you will be having as a smart contract designer, you may have to provide a UI, or the blockchain designer. You may have to give an UI for each entity, and what is being accessible and what is being need to be shown to them, and accordingly it will be there. And the digital signature is going to confirm these operations. So when you are having that code written, you'll be having the front end and back end. Along with that, you will have REST API, with API, all this remote processing call, all these areas. You need to be strong if you're going to be involved in a blockchain developer. And in turn, what are the right? You will be having an immutable shared ledger. This ledger is going to available for all the entities in the network, and we'll have this hash function, which is kind of a previous block hash. So what does that means? This entire block, okay. So this block, the entire hash, is going to be provided as a hash here, and the entire block, hash is going to be provided here as a hash. So which means, right, if you change anything, the entire block hash will be affected, and then it will be too difficult, to edit the content of that particular, blockchain ledger. So that's how we ensure that. Okay. So that's how we ensure the blockchain ledgers are immutable. And when you are starting with the block one, if it is going to block 1,000, then the block one is more secured. Block one is more secure, because if you need to penetrate to block one, then you need to penetrate all 999 blocks successfully within that time duration. Because if you take a Bitcoin, each block creation time is 10 minutes. So which means within 10 minutes, you need to get into the hack into 51% of the network in online. Because if you see the Bitcoin concept, 51% of that machine need to give the consensus. So if you want to change some fact in Bitcoin network, then you need to have a worldwide attack on the blockchain network. You need to capture 51% of that machine which are in the online currently need to be attacked, captured, and you need to edit the block in the blockchain within 10 minutes. Within 10 minutes, and then you have to close it, and then you have to freeze it, and you have to come back. So which is very costly, because whenever the hacker going to attack something, they see what is the investment they make and what is the benefit they get out of it. When they have no profit out of it, they're sending put a lot of energy and there is no profit out of it, they never go for trying and hacking that particular part. The same thing with your blockchain network. When your network is being healthy enough, and then it is too costly for them to spend a lot of money. That is where they come with that area where the vulnerability is involved and to attack that part. One such area is where your smart contract. Before that, in the blockchain, what we try to do here is we have the distributed shared data peer-to-peer network needed. You need to understand this, and you will have a self-executable smart contract. When the conditions are met, the smart contract will be executed automatically. And then your consensus mechanism to create the trust among the trustless peers. You are not trusting the peers. Among the trustless peers, you need to create a trust. So for which we have a consensus mechanism. And then your cryptography models, methods, all those things, and the hashing part for data integrity, then your immutable transaction records and permission, private or public network. All these concepts are, we need to understand in the blockchain, and which is helping us to move from centralized to decentralized model. Okay, so we are moving, the transition happens from centralized ledger to distributed ledger with the help of these concepts. And with this, we are going to get the benefits, the improved transparency, all knows what is happening there, and single source of truth. No one can change anything because that ledger, distributed ledger is going to have the single source of truth. And then automatically the trust, that is your self-contract, where we are creating the trust, right? This automated trust. So, and then your immutable data, all this, then reduce the cost. So over the period of time, it is going to reduce the cost on this one. Okay. So in a blockchain, we can achieve all this, but the room for error or where we got very careful is one possible area is a smart contract where this is where we are actually focusing on area, one such area. There is a lot of areas where we can have to focus, but one important area is smart contract. But before that, we can see that worldwide, which are the companies are using which type of blockchain. So this is that from the 2022 data. Okay. So top 100 companies across the globe, they are using what type of blockchain network in their business process. Not entirely, but some of the business process, they are bringing blockchain into the process. So if you see this, right, Hydrogen Fabric used by 38 companies, and the Ethereum used by 24 companies, and then Quorum used by 17 companies. Coda, it is mostly for financial transactions, used by 13 companies. Then Pharma Ledger, which is for pharmaceutical companies, the 8 companies are using, and then Bitcoin part used by 5. And then you can see the Medi Ledger, medical company, right? Pfizer and Roche are using this blockchain. And then AKT, Antchain, Multichain, Federa, and then your Kumbo, Axoni, all these are being predominantly used by the top 100 institution. Okay. So now, if you see this, all this one other than Bitcoin, all comes with that enterprise blockchain with a smart contract support. There is no smart contract in Bitcoin part. So Bitcoin is only cryptocurrencies involved. But other than that, all enterprise one, which comes with that, private public chain or, so only certain group of people can enter, and then you have to know who you are. In Bitcoin, it is a public blockchain, which is completely, anonymous network. But when it comes to enterprise blockchain, it is not an anonymous mostly, because you need someone to authority, right? Some authority will be there to approve their role in that particular network. So the network operator who knows that who are entering in that particular network. So in private blockchain, the anonymity is gone. We can't say it's anonymous. But when you come to the public blockchain, it is completely anonymous. We don't know who is or involved, who is having most of the money. It's too difficult to track, even though there is some mechanism involved, but it's too difficult to track the actual one. Okay. So when you are as a smart contract developer, okay, so when you are writing a smart contract, I'm just giving a very high level. You need to select a platform. As we have shown in the previous slide, we have Fabric, Coda, Ethereum, Cordana. There's a lot of platforms are there. Which platform you are going to write? It depends on the business the problem you're going to solve. And then you need to select the instrument for which instrument you're going to write the code. That is, is it for supply chain? It's for logistics, or it is for tracking an asset, or is it for tracking money or storing a financial transaction, or whether it is a bond or it is a equity or something. So you have to say what instrument you are going to write a code for it. And then the smart contract development, you need to write a code with the conditions that when to trigger, and all those comes under this part. And then the most important part is testing and audit. This is what our focus, the testing and audit. That is the aim where we try to avoid the issues from there. and then you have to deploy the contract in that platform which you have selected. So the audit, the testing audits are very important because in a normal business application, the testing, we have a number of testings are there. Even if something goes wrong, we can able to roll back, we can able to bring it back. But that's the problem with our blockchain. Blockchain decentralized network. When you say DApps, decentralized applications are running on Ethereum, which is too difficult to roll back, and it is going very costly as well. And once that is may happen, the trust it will be too difficult to earn the trust again. So all these reasons only this audits are testing as something different from the normal or conventional method what we follow in our data application. So why it is important, how we can do it simply, that is the next part of this session. Okay, so when we have this decentralized autonomous organization, that is we call it DAO. There is instead of someone is taking a decision, the network is going to decision based on the information. So DAO, that is what proposed after the successful launch of Ethereum, decentralized autonomous organization. So this is completely based on the smart contract. So the entire activities are written, n number of smart contracts are involved. So the smart contracts need to be carefully written because if there is any buggy code or if there is any kind of data types misuse or that agreements are not properly written, then naturally what will happen is it will create a lot of disputes. And what is the problem is you can't go with the court also because the jurisdiction, when you have this global, if you say, for example, in India, when you have the companies there, if you sign any agreement or anything, they'll be say this comes under which jurisdiction. Suppose if the company is registered in Bangalore, then if you have a problem, you have to file a case in the Bangalore court, not in Chennai. So if there is a company you are involved and the company headquarters in Delhi means, then you have to file a complaint in Delhi court. You need to go there. So like that, the jurisdictions is very important. The same way, when you have a global company, which jurisdiction they are following, right? That is where say Indian subsidiary. When you say Indian subsidiary, they have an Indian branch, which means they comes under the Indian rules and regulation. That subsidiary, right? Like that, we have to follow rules and regulations. Arnold one. But when you come to blockchain based, there is no jurisdictions involved. There is no court disputes kind of thing. So you need to be very careful. The agreements when it is executed, this execution is final. That is finality part, which is one of the property in blockchain. So the code, something is being written wrong, then it's going to be really tough to bring it back, and the money, if you lose, then you can't take it back anything. For example, even if your account is been wrongly credited with some 5 crore, and then what will happen most of the time, right? If I am an honest person, I'll go in from the bank that I got 5 crore. I don't know how it is thing. But if it is a dishonest person, then I'll try to take the money immediately. I'll try to spend it. If the bank identifies that it's wrongly credited, when they come back and ask me, it is too difficult to get that money back because it's their mistake, and they have to pull in a lot of other things in place and to take that money back from me. If I'm a honest person, I will give it before they come back to me. I will be informing the bank and I will be sending it back. But in the case of your blockchain part, it is too difficult because if there is a lot of entities involved, and rolling back would be too difficult. And that is where the smart contracts is really tricky in terms of audit, in terms of validating it. Right? We have different types of attacks are possible. If you see, anyway, we'll be in this session, we'll be focusing on one particular part, that is a re-entrancy attack. But other than that, other things we don't have enough time to speak on this particular part. Denial of service, most of you know, the force feeding, Oracle manipulation, the entire data set has been corrupted. This is Oracle manipulation, front running, time sum dependence, insecure arithmetic. That is based on your data type. If you are using wrong data type, then your arithmetic may go wrong with it. And then insecure means you're not having proper lock when you're doing the arithmetic operation. Then griefing, all these are different types of risk involved. But most important is a re-entrancy attack. I'll tell you why I'm covering this part. Okay, so now this DAO being attacked with this re-entrancy attack is happened. I'll tell you what is that later part, end of this session. So what happened in June 2016, the DAO organization was exploited with that security breach, and almost they lost 3.6 million Ether and that at that point of time it was value around some $50 million. Okay, so how it happened, how this particular attack has happened, and that is after this only this auditing, there is smart contract audit, and then a different method to validate the code it came in picture, strongly. And what happened is, let me go through the timeline. So if you understand this Ethereum concept and all, right, 2014, the idea of Ethereum was proposed by Vitalik Buterin. It's an innovator. What is interesting here is when he was proposing that Ethereum, the Vitalik Buterin was aged 14. He was only 14-year-old when he was proposing this Ethereum. And then they had some creator, some 3 or 4 people joined together and they created this Ethereum platform, and they launched in July 2015. And over the period, they come with that concept of DAO, that is, a traditional organization where the decision making will be top. For example, if you take Tamil Nadu as a state, CM is the decision maker. If you take Indian government, India, for our prime minister is the decision making. So this is how the traditional organization works. In your college, your principal is decision making, or the management will be taking that next level of decision making, right? But in the case of your DAO, all the members who are involved in that one will be involved in the decision making, which means the proposal will be made and sent it to all the people in the network, and they have to vote. When the vote is successfully completed, when there's majority people voted, then that particular contract will be executed. Okay, and then that particular actions will be triggered. If there is that particular voting is failed in, then that proposal will be withdrawn. That's it. So it's a kind of a democratic organization where everybody will have the equal rights, and then when something is proposed, the people will be validated. So for example, imagine when some rules is bringing into government, right? Instead of that, if all the people, each and everyone is validating that, and then they give a vote, and then to say, yes, this is what we need. Like that, if they agree upon the, oh no, we don't want it, they reject it. So now the actual powers will be in the people, right? Which is what they try to provide with the DAO, a decentralized autonomous organization. Okay. But for that one, they launched this the idea DAO, and they were starterizing function. And what happened is after launch, right, within the 2 months, in 2016, the DAO was hacked. What is interesting is before that happened, there is a lot of serious timeline. If you see this, some interesting things happened over there. Okay, in June 5th, what happened is the vulnerability was being identified, made public. That is some people, the group of people in a general interest, they were saying that there is a flaw in the code, and which will create problem and the balances. That is the account balance, Ethereum Ether, right? They have that account, right? That can be emptied by an attacker. That they were, the people were telling about this problem, vulnerability. In June 12th, the founder were going through this one, and they were dismissing the threat. It won't happen. It is not going to happen because we have a workaround loophole is there, and it won't allow that things to execute in the framework, and your account ledger is safety. That means your account won't be emptied out. Your money is secure. But what happened is in June 17th, immediately, within a week, the DA was attacked. The same vulnerability which has been informed to the public in June 5th using the same one. And within the next 36 hours, almost $50 million worth of Ether it's drained from the wallet. So the individual wallet has been been taken that money out of it. So this is that attack happened. And it's a kind of oversight from people. There are people being informed this won't happen. There's a problem, we need to fix it. And that founder denied it, and they dismissed that request or that information. And then June 17th, that happened. And by the next month, July, right? So they did a lot of things to roll back to painful operations happen. In July 16th, what they did is they did the DAO. So to make it happen, originally they did a voting among all the members of the network. So what is that, right? The hard fork, the resulting in Ethereum Classic. They split this network into two, Ethereum Classic, because of this attack. So now what is that in July 15th, in an exactly 1 month later, they established a voting mechanism to see this, right, whether to have this platform, or we need to have a hard fork to avoid this kind of issues further. So that is where in July 20th, this hard fork happened. So that this attack, the DAO attack, after this one, they divided into two to ensure that this attack won't happen again, and to bring other security network or the contract, all those things being updated accordingly. Okay, so now after this incident only, this smart contract validation is been a kind of a top priority for blockchain contract area. Okay, so when it comes to the blockchain security, as already mentioned, right, we have multi-layer protections are involved, but most importantly, what we are protecting here is the smart contract area. The smart contract is our execution, autonomous execution point, and we try to do some audit, manually, and then we do some formal verification. These two are some different method we are focusing. There's a lot of other things other, but I'm just highlighting these two here in this session. So when you're having this, smart contract, what are the possible issues might come is the three possible things might happen in a smart contract if it is not properly, debugged. So the integer overflow, using wrong integer variable, or without thinking of that, what is the maximum value might happen in next 10 years, 20 years. Will it be the same value? Will it be increased that, number of digits will increase? And if you are using wrong, data type, then it's going to create an overflow issue there. And then function specification issue. For what function, right? What is that you are trying to achieve with that function? That function specification is not clear, then it will be a problem. And the invariant issue. So there are values might be variable and like constant. So we might think some values will be constant, it won't change. But in future, if those values are changed, what will happen to that contract? Whether it will work correctly, whether it will create unnecessary problems. So the invariant issue, we need to thinking that these values are going to be constant for next 10 years. But what will happen if after 10 years or before that some government changes or some process change happen, or like in industry there is a lot of new things will come in. So some new process can come in which makes that field to change the value, then that time it will be a problem. So invariant issue. Then your authority control, who is having the authority to give that, to trigger that function, to whether if that person is still there, or do we have any hierarchy into that one to give that authority? All those things need to be validated. And then the behavior of the specification. We might be having an intention to do something, but internally it's having a different behavior, which means that the logic of that function is not validated properly in all dimensions. Then the behavior is going to be something different. It is not an expected behavior. And that is what happened with the DAO. So the DAO part, that attack, re-entrancy attack is happened because of the behavior. They expected some behavior, but it has been exploited, which lead to some other behavior of the same function which is being there. Okay, fine. So how we are going to do with this is, the first one is our audit, smart contract audit, where it's completely manual only. So where the experts will be sitting there, and then we go through that, understanding that the function are not involved, the entire domain, and then they will be check that code one by one, because it's the irreversible process. We can't reverse it. So the smart contract audit involved with vulnerabilities need to be fixed, and then the security is being brought in correctly or not, and the trust part has been enabled properly, and then for which we do n number of peer code review. So if I'm writing a code, I might oversee that problem with my code. So my code will be given to another developer who will have no idea who developed the code, who created it. He will know only that the ultimate aim of that module, what we are trying to achieve, the expected outcome, and the input, what is the input. And that the peer review will happen, and we will be say whether it will work or not. Like that, there are many people in that network will do the peer review. So there are organizations who are doing this particular work, that smart contract audit organization. Those will employ a number of people in the network, and they will be working remotely across globe, and they won't have any specific config structure and that. They will be going through that code, and they will validate whether the code will work fine or not. Okay. So to avoid this costly exploits. And for which, what are the possible things can be addressed in smart contract audit? One is the security flaw. If there is any improper, security protocol is been used, or the version issue, or is an outdated mechanism, or 32-bit, 64-bit, like that, the number, the bit difference, all those things will be addressed. And then, is there any dependency with the third party? Third party dependencies, you got to very careful, because if you're depending on a third party library API, that API may be corrupted, or that API may be hacked by someone, and then it will be a problem. And so you need to be very careful when you're using third party API, because the third party API, we have no idea whether it is tested properly, whether it has been validated properly, because it's a closed black box entity. It's a kind of black box entity, so we don't know what is inside exactly. So in the case, whenever you have this third party dependency, we need to validate manually, and we got to check what is there inside one. And then your bugs, operational part of the bugs, and then your design inefficiency, that is a delay, unnecessary delay, which is costing that smart contract to delay to execute in time, right? And then code quality issue and complaint check, all this re-entrance attack. That is also can be validated with the help of your smart contract audit. But that is through peer code review. We can able to avoid this one. So what has happened with the DAO attack is a re-entrancy attack. Okay, I will tell you that after this, we'll tell you what is a re-entrancy attack. Then your overflow, underflow concept, all this can be avoided or can be addressed with the help of audit. But what is the main problem here is, right? It's a manual process. Okay, so the entire thing is, right, that we'll be doing a lot of different analysis. Will be static analysis, dynamic analysis, and then manual code. For static and the dynamic, we have some tools. Some tools are in process where we have sandbox, which will do that. But apart from that, we have a manual code reviews also there. To if that is not going to be tested in any of the sandbox, then we need to do a manual review. So in this one, different types of audits are available, and with this we try to remove the bugs over there. So in the smart contract audit process, there's various steps are involved. The first one is you need to collect all the design model, what is the architecture, and then the what are the third party smart contracts involved. And then we need to test them separately. And then the unit testing. Unit testing is what going to happen with all this thing, all the model which we're going to do a unit testing. Okay, but unit testing, it's a kind of repetitive. We are going to do multiple small talks over there. So in that unit testing, whatever the result comes in, we are going to do a manual analysis, and we're going to inspect and introspect what is happening there, and then we try to see that attacks, especially the front running attack, and then the device attacks can be addressed over there. And once we know that, overall how many the dashboard we'll be trying to create, how many smart contracts and whether we tested properly or not. If it is not, then we do this, it's a kind of cyclic process. So if there is anything identified, then we compare a fixing error or fixing bugs, and then we will do this analysis, static analysis, dynamic analysis, and then this is kind of a repetitive process for each and every module, for each and every code which we have written, right, or which will be happened. Once it is done, we'll give the final audit report. So the third-party agency, the audit companies are there. So they have a separate role to play. They will be paid for that one. So these independent audit agencies, so they will be mastered in a blockchain part. They will deploy their resources to do this kind of an audit process, and then they give that one whether that particular the apps or the decentralized application is ready to deploy or not. Okay. So even though we do all these things, sometimes it is too difficult because of some manual parts are involved in this particular process. Okay. So we do static analysis, we do have dynamic analysis, penetration testing, and then gas optimization technique. Gas optimization, if you have studied Ethereum, where that ether is there, and then we have a gas. So we'll be using the ether to buy the gas. And most of the time, whenever your function, the smart contract or any code is been executed, the gas we need to spend on it. The fuel, it's a fuel. So if that function need to execute, we need to fill it with enough gas so that the function can execute. And this ether gas, right? The gas we need to procure, you need to buy by spending your ether. So if there is a question I want to ask, you can think on it, and I'll answer it. But I don't know whether you have this question or not. Why they brought this concept of gas? Okay, anyway, the gas you are going to purchase with the help of your ether only. So why can't you can directly map to ether? Like if to execute this particular a block, you have to, spend money, you have to give money 0.25 ether. Instead of that, they mapping to gas, any particular reason you think of. So if you see that right, each lines of statement execute in decentralized, app, that is your Ethereum decentralized application network, where you're going to deploy your application. If you're going to deploy your application, you need to have enough gas into that one, and then the gas you need to purchase with the help of your ether, right? So why they brought this concept? If you, I don't know whether you have the answer or not. If you have it, well and good. Otherwise, I'll tell you the concept again. So if you're running, if you're riding an, if you're going in a car and the car is suddenly your brake is failure. You have seen various movies, right? Tamil movies where they try to stop the car indifferently. So what are the way to stop the car? If you see this, if you don't panic, then you are going to get into accident. If the road is flat, then what will happen is if you switch off your car, then when it goes down slowly, then you can able to do a lot of different approaches of that. But one basic thing is whether you want to switch off your car or you want to do something else. So that is different one. But apart from that, very very basic thing is when the fuel is empty, when there is no petrol at all, there is no diesel or there is no gas, now your vehicle will automatically stop. Given that if there is it's a very empty road and there is no other vehicles are coming in, against you like that. But in general, when the fuel is empty, then your vehicle is going to stop. The same concept they try to bring in decentralized application network. So when you are deploying an application and the application is going to run in the decentralized network, suppose imagine if something is wrong with that application, then you can't stop it because you already deployed. Your application is running on the network. You can't stop it. So what is the way you can stop it? Is one is if you don't give any gas, if you don't buy additional gas, then that particular function will stop naturally. So that's how you can come to bring the smart contract to the end by not giving enough gas. So as long as you give the gas, the smart contract will execute. It will keep on function in that network. But when there is no enough gas, then that smart contract or that module will stop. So that is where they bring this concept. So when there is no gas, that particular contract is not going to execute. And then you can roll back or you can bring an additional or a new version of the contract can be deployed. But it is wasting your gas, wasting your money on it. And the same way, right? If you are using an unnecessarily execution, right, multiple times, and then that your code is not efficient, the gas is going to be wasted. That is why the last one, the gas optimization techniques, will be bringing on home. But apart from this, right, we have another method is formal verification. That is another one. So when to go for this formal verification? Why smart contract audit is not enough? Smart contract audits most of the time is manual review. You need to bring in some security expert to go through all this. But in the case of formal verification, it is before the hand, before you start actually using it, the mathematical methods are being brought in the system to prove that contract correctness, which means before you design it, before you actually code it, we bring the mathematical models methods to prove that contract correctness, and then against the predefined specification. So everybody knows what is going to happen, and then the code the smart contract developer is going to develop the code according to that one. So that the flaw, the risks are very very minimal when we go with this formal verification approach. And also another one is when you have this formal verification is when you are going to involve a lot of money involved, a lot of things are in high stake. Say in the complex contract, in those cases, that formal verification is very, because in smart contract, when we validate, we may tend to miss out one particular class, one particular case, right? That is multiple switch case, multiple events. We might miss out one particular in a case. So to avoid it, when you have a complex contract or the mathematical the result is it's certain result you are expecting. Accuracy is very important. In those cases, we'll go for this formal verification method. So the comparison, putting to the right smart contract audit and then your formal verification, it is formal verification much more important because it's a mathematical proof. So once it is proved, then there is no way it's going to get wrong, and that is what is being predominantly used, and that is where your mathematical knowledge. When you study in engineering, that is where every semester you have mathematics, because in any concept whatever you study, they are all connected with mathematics. If you understand the mathematics in depth, then you will understand the concept as well along with it. Okay, so the human involvement will be high in the smart contract audit, but in the case of formal verification, it is not. Only in the initial specification you are creating at that time. Once it has been created, when you have deployed that smart contract according to that formal verification method, then you don't need to worry about that further. Okay. So in the formal method, which has been in cybersecurity, we are taking this formal verification from the cybersecurity world, right? That is where the formal methods concept used. That your mathematical logic, mathematical proofs are there to construct that secure system, and they come with the two area. There is a category which is one is formal specification and then verification. Specification is what you are trying to achieve with the specification. What you have to write it specifically what you are trying to achieve, and verification is whether it is going to happen is correctly or not with the correct proof, justifying that justifying that specification which you have mentioned. That is two part. So you need to specify what is you are trying to achieve, and then whether it is possible or not, you are going to verify it, and with that mathematical model. Okay, so when you have this formal verification in place, we are going to have the smart contract. You are writing the proof, right, to say that this is correct, to prove or that validity of the contract, before you actually execute. So the mathematical model is going to verify that smart contract is possible or not, whether it will create any problem issue. All those things are being modeled out, and then we are going with that deployment chart. So it leads to low human intervention in this part. Okay. So, but even though we have this formal verification, right, it's kind of mathematical models involved, and we have a lot of tools we're going to use to prove that, to do the model checker, and then the theorem. We are going to write a theorem that we need to prove that, verify or validate that one. And that is where more research involved. So when you say the blockchain related research is happening, is most of the research happening in this area. That is how to validate the smart contract, or what are that mathematical proof theorem we can come upon to validate, because it's a decentralized, many people involved. You can't stop a function. For example, if I'm hosting an application in my server, if something wrong, I can switch off the server, and then I can take off that application immediately. But when I deploy it in the DAO, that is your distributed network, decentralized network, distributed network, whatever it is, that's that Ethereum, right, across the entire globe, all that machines need to be shut down. Then only you can switch off that application, which is not possible, because even if one machine is running in somewhere network, then that the smart contract is active on that particular network, on that machine. So that is where it is too difficult when you have that decentralized model, and that is where we have the tools, some different tools to validate this, like a selector, approver, and COQ. We call it as COQ, are used for this formal verification, because before you create the smart contract, we are going to design that contract, and then we are going to validate it with this tool. So it's a separate area. It is completely mathematical based. You can take, if you are interested in this, take a look at it, and you can understand what is the tool. So this is where I highlighted the tool in this part. Okay. So we can check on this further, and to know what is happening, what we can do with these particular tools. Okay. So, okay, fine. So now, what are the limitation with this particular formal verification model is, it is, verification is computationally expensive, because you need to, spend a lot of money on it, because you can't, execute all this smart contract in the real time. So you need to create a, sandbox, or kind of a product system where you need to computationally, you need to validate them. So it may be more expensive. You need to bring experts into that one, and then somewhat costlier than the other method. And the logic which you are writing is going very complex, which means you have to be definitely bring some experts. When you bring an expert, you have to give more salary or payment for them in order to do that. and that is why it is kind of a costly. But it is better than go with an audit. So nature of your for what purpose you are going to bring smart contract. If it is a normal small activity, then your smart contract audit is good enough. But you are going to do, for example, for Indian government want to do something, automated some of action. And in that case, they will be not going with an audit. They'll be going because the entire country is going to affect it if they make some mistake in that logic or in that smart contract. So in that case, we'll be involved with many experts to validate it, and then they will be going with that particular one. Okay, fine. So. So this is that approach. So when you have the formal verification one, the smart contract, there is overview how we go with that one. So we'll be deciding on the data types. What are the data types, and then you are a safe math library. So the library we have blockchain specific libraries are there, right? If you go and check it, Hyperledger or Hyperledger Arsha, it's one specifically for a library, mathematical cryptographic library. All right, decentralized. If you want, you can say the Hyperledger part. They have a specific library for it. Like that, there is a lot of libraries API specifically for blockchain mathematical part. So we need to get those library, and then we need to bring this automatic tactic concept, which is a separate area. We need to explore more on that part. And then the abstract model will be created, the state, the contract state, which the event, when to trigger that the event abstract, and then what is the message need to be sent. So we need to write a code. It's all our abstract method. So the developer need to write a code for it. And then the abstract environment, that invariant part, the invariant attack, right? The issue can be resolved with this model. And when you're writing the code, the solidity, here is writing solidity code for the Ethereum. Then that you need to define your state model. What are the state you're going to capture? And what are the events you're going to trigger, when to trigger, and then what is the message you're going to do. So all those models you need to create, and then that specification, that is your model function, right? Your function modeling part is happening. So the specification is given there to verify whether that logic will work correctly or not. And then the function properties, where we have the function behavior will be analyzed, and then authority will be verified. All this verification is going to happen. Okay, that's it. So the verification part, everything is a mathematical is involved. And as see in the previous one, your code is going to be created with this defining the model, by defining the event, a message, what is the message, and everything is verified with the help of your formal verification based on that specification, formal specification, what you have mentioned for that particular one, for the particular smart contract. So in the DAO, what happened is the attack, the reentrance attack is the hacker, they had a fallback function, which will be calling the withdraw, right? But before it is closed, before it is completed, and before it is completing it, right? That is where that flaw they identified, right? It will call back. There is kind of recursively, this keep on that looping. So recursive call will happen continuously. So what happened is it will take the balance. It will take the balance from the DAO, but it won't update the balance. For example, right? It will show that the balance is still there. But you are taking that money out of it. So all that money will be, sent to the hacker's account without freezing it, without finishing with that one. So what happened with this one? Each time when the withdraw function is called, the smart contract, the DAO smart contract, try to send an amount of ether amount from to the hacker's deposit account. And but what is happening is when when you're actually sending that money, we need to finish the transaction. When they finish the transaction, then only informing that function is finished, and then that you'll go to the next action. But instead of finishing it, right? This vulnerability, what happened is they didn't check whether the function has been finished or not. Without that, they're sending the transaction, it is didn't finish, and the hacker, what they did is, before ensuring that the function is finished, they were calling in a fallback, finishes executing, right? But that fallback, within the fallback, they were doing another withdrawal. So like that is they keep on, withdrawing money from the account, more than that allowed limit. Suppose they are giving a permission to withdraw 100 ether, imagine like that. So I have given permission in the smart contract to withdraw 100 ether. And now the hacker is coming into the network by depositing Ether and got that authority to execute that particular smart contract. Now the hacker is triggering that the system doesn't know he's a hacker, right? The hacker is now triggering that particular method. Now automatically what happens is before finalizing it, that money is being sent every 100 Ether is going back to the hacker account, and because the function is not finished. Within that, we have another withdraw, either just keep on coming. And that is what happened with that, DAO attack. So it is a sample code, just for your understanding. If you know the Solidity code, very good. But anyway, I'm highlighting where is the problem is there. The problem is here. So the update user balance is 0. When the balance is 0, we are trying to update the user balance, and then this is where we're trying to withdraw function require, then your balance message center, and then we have to. So if the purposefully, right, if that is the balance is been we need to give the final report. If this is not called, now what will happen is this will be keep on triggering that particular function again. And if you see this right, how we can resolve this particular problem in DAO, that particular DAO issue. That is, two solutions can be achieved. One is by removing that code, this the part. If you remove this code, then naturally this will be stopped over there, and we can able to bring it back that condition, and we can that attack could have been avoided. Okay, that is one simplest one. Resetting to 0. That is, before we start, they said resetting it to 0. So every time that function starts with a 0, that is at the end of that one, they are setting it to 0, which means that making that system to believe that system didn't trigger that function. And then again, they start the new function with the same value. So if you remove that one, that color balance reset to 0, if it is been removed, then which means that that amount is withdrawn, and then the smart contract can come to a halt. Okay, which is missed, which is a costly miss. Okay, there is one way. Another one is they didn't lock it. That is, they didn't bring a lock. Hope you have the concept of lock. If they have bring it locked internally, right? If they are going to get into the ledger to take the money, if it has been locked already, when you are calling it again, that is a recursive call, right? When you are calling it again, it can't happen because that particular one is already locked. So which means that it won't go further until it has been released. That won't be executed. Even that part has been missed in that the logic. So these are some solution. They come with it, and then if this has been already identified, the founder of DAO, if they didn't dismiss that vulnerability addressed by someone, if they have really taken care into that one, it could have been avoided. This is how they exploited. That doesn't mean that that there is a room, the actual logic in the DAO, to support this was being exploited, okay, through this kind of simple code. Okay. So that is all about from my end. With this, model, right? This particular, attack, the re-entry attack could be, safeguarded. So by this smart contract audit, we are going to validate the action. Whether this happening correctly or not. In the case of your formal verification, with the help of mathematical specification model, we try to visualize that entire thing before we actually create and deploy. And then as per the rule or theory, mathematical theorem, what we validated, that code will be developed accordingly. So there is a less chances of getting that issue. And if there is something happens, it's going to be really costly. That you have to lose a lot of money as well. That's how we can go with this one. Again, this is a vast area. Just given in this session, what is that blockchain, what we are trying to achieve, how we are moving from centralized to decentralized, and how we are going to do this automatically with the help of smart contract, and how the trust is being enabled in blockchain by the help of blocks are created, hashing, and then the structure of the block, which we have a kind of look, and then the smart contract, when it happens, what are the possible things can go wrong with that DAO, right? As an example, what happened with that. And because of that, the blockchain security comes into a vital role. And in the blockchain security, even though our ledgers are kind of safe, but wherever the manual part is involved, we need to be given more security. With respect to that, the blockchain and smart contracts need to be validated, verified before we deploy it in the real-time environment. So for that, we have two majorly used approach. One is your smart contract audit, and then formal verification. Smart audit, which is majority manually, you need to do validation. Along with that, you have static testing and dynamic testing analysis are there. But in the case of manual verification, we need to create mathematical models and all. I didn't show any mathematics here because I need more time for it for a sample logic. We need to create a model, how to create model, and then how to commit the validation proofs and that. But instead of that, just given that re-entrance attack, what would have been did or to avoid that attack can be, to avoid that attack completely. Two solutions. One is by not allowing that method to bring back that zero, right? Again, changing that value to zero, that is can be checked. And another one is by giving a lock, because many people are going to work on that, ledger means at a time, you can have a lock and then you can release a lock once that has been updated. By the time, with that one, that fallback when the withdraw comes again, trigger it, it won't allow it because it's already locked. And that's how you can able to avoid this re-entrancy attack. So re-entrancy is nothing but before executing the logic, again you are re-entering the same logic and then you are executing it before ending. So like your recursion. Recursion, if you are not having a proper exit, what will happen? It will keep on execute, right? And then in here, in a normal machine, once your memory is gone, then your machine will crash. Okay. And in the model languages like Python, the recursion will not go up to one level. Automatically, it will stop it because that the stack depth is not allowed certain height, and then it will come out. But in the case of your decentralized concept, the network is worldwide, so the machine can take the resources from anywhere. So it will keep on running, taking all the money out of that your Ether account, and that is what happened with that 2016 attack. So, any questions? Anything?
If anybody is having any questions, so kindly interact with sir. So no questions means so I will conclude, sir.
Yes, Professor. Okay. So
Yes.
thank you all for joining the session and listening it patiently. Also, those who attempted to take the quiz, I appreciate all of them. And thanks to the college management and Professor Arnold for the opportunity to share the knowledge on this one. Yeah, thank you.
So thank you, Rai sir, for giving wonderful talk on blockchain security. You have started from blockchain security and covered a smart contract audit and various methodologies in smart contract, the formal verification, and how companies are using smart contract, about DAO. So everything you have covered. I hope those who have attended, surely they would have gained good knowledge over this blockchain security. That is from smart contracts to formal verification. Thank you, sir, for sharing your valuable knowledge. At this time, I would like to thank our management, VC sir, for approving this talk series to invite Rai sir and conduct this. I thank our principal sir. I thank our dean academic sir. I thank our dean research sir, our HOD sir, and professors in our department, and senior faculties in our department, and all other faculty members. And I thank Regin sir for creating a host link and Zoom link and live stream and everything. I thank all the students and faculty members who have joined from other our group of institutions and other departments in our college. I thank everyone for having a good session over blockchain. Thank you once again. Thank you, sir.
Thank you, Rai sir.
Thank you.
Thank you.
Thank you,
Thank you,
sir.
Rai sir. Thank you.
Yeah. Happy Sunday.
Thank you, sir. Happy Sunday, sir. Thank you.